Hi everyone, welcome to the video for section 4.6b. This is the last graphing section in our unit 3 for the spring, and we're going to finish up learning the last two trig graphs, and I hope that these will be the most straightforward for you because of the experience you have graphing the other four. So let's look at our first one. We've got the cosecant of x, y equals the cosecant of x. If you will recall, the cosecant of x, let me get that smaller, okay, is the same thing as 1 over sine of x. That was the reciprocal identity and something you could really kind of consider the definition of cosecant. And so it's definitely related to the sine graph, but it's related in a way that you'll see in a moment is a reciprocal relationship. So just for a reference, I'm going to graph the sine of x on this curve, on this coordinate set of axes as our first step right here, and it will help us draw the cosecant. Okay, so this is just, I'm going to do it as a dotted line, and let's see, we got to fit it in. I'll put 2 pi there, which makes this pi, and then over here we'll do, of course that's 0 right there. But this is negative pi, and this is negative 2 pi. I think many of you are learning to label your own axes, which makes it a little bit easier to do. I'm going to make this 1 and this negative 1, just so I don't have to squish it down too flat. And I'm going to draw this in as a dotted line. Okay, so we know graphing sine that the period starts at 0 and ends at 2 pi. It'll cross the x-axis in the middle, and at our quarter point we go to our max, and at our other quarter point we go to our min, and that is our first period. Okay, so we put arrow on the end. Then I'm going to draw the other period to the left here, draw in my 5-dot pattern, and oh, I didn't draw it dotted. I wonder if it'll let me go in and make it dotted. Let me go ahead and draw this one dotted. This is not actually part of the graph of cosecant, so we don't want to draw it solid, implying that it is. So I'm going to see if I can't go in and actually make it dotted with an eraser. But it is a guideline to help us draw the cosecant of x very easily. All right, so let me borrow this little eraser here. See if I can't erase enough pieces. Okay, yeah, that makes it look dotted. Okay, so, all right, so there's a dotted line, and sine is our guideline here. Now, one thing you need to pay attention to is where this crosses the x-axis, okay? Because if I have places like, I'll even put a red dot there just so it sticks out. A place like, get the right tool here, like right here, that crosses the x-axis there and there and there and there and there. And what is the y coordinate in all these places? Well, that would be 0. So the sine of x can be 0. It's 0 specifically in these 5 places that I've actually drawn. Now, it does go on infinitely, but I'm only concerned with the ones in my picture. So if I were to put 0 on the bottom of this fraction, that's undefined. Well, in the curves like tangent and cotangent, when we had places that were undefined, we put dotted lines called asymptotes. So everywhere that this curve hits 0 is a place where this curve is not defined. So the places where sine crosses 0 tells us where to put asymptotes. So we're going to do that. I'm going to use my straight line tool and put in asymptotes everywhere that sine hits the x-axis. And let me actually make the line a little bit thinner just so it's a neater drawing. So right there is an asymptote, and everywhere it hits the x-axis. Notice it's the same distance between them, 2 boxes in this case, or however you decide to scale yours. So we know that we never draw the curve in such a way that it crosses an asymptote, which means that Cosecant is drawn in a bunch of little bitty pieces, just like tangent is, okay? Now, I'm only going to draw these two periods because it'll be the same as all of the other ones where we've drawn two periods. Now, I'm going to give you a couple pieces of information about this graph. Because it's related to sine, it has a period of 2 pi, just like sine does. So it's actually going to take me from, say, 0 to 2 pi to fit in one whole period, but you see there's an asymptote in the middle of that. That actually does get chopped up into two pieces. So this is an unusual graph. But we really have to think about what it means to take a reciprocal of a graph, okay? Now, I will give you this hint that the amplitude is 1, like it is for sine, but we don't really call it amplitude because this curve isn't a wave either. But if you just say A is 1, I'll understand that as the vertical stretch like we described it for tangent and cotangent. So to flip something inside out or flip it upside down is how to take a reciprocal. So what do you think the equivalent idea is on a graph? Well, think of it this way. If I were to take a pair of scissors and chop this curve off at the red dot here and at the red dot here and invert it, it would be a kind of a U shape upward. All right, so let me draw that in for you. I'm going to draw it in black. So the actual curve, y equals cosecant of x, is just going to be what I draw in black here. It kisses, it's right there, it kisses that value, and then it gets flipped inside out. So this orange hill gets flipped upward, and it looks kind of like a U or a parabola. Put our arrows on it. And everywhere there's a peak or a valley, think of it getting chopped here with scissors and flipped the other direction. So this turns into a hill. All right, and just go along, and every peak and valley you draw your U shape. So what I'm drawing in black is the actual curve, cosecant of x. And the rest of it is all done in dotted lines because those are just guidelines that help me draw it. Okay? So in black here is two periods of y equals cosecant of x. Does it make sense that when you flip something inside or upside down for a fraction, the graphing equivalent is to flip the pieces of it? You would actually, like if it was an actual piece of string, you would take scissors, cut it here and here, and flip it up in the other direction. It's kind of interesting. So we connect the U's at the peaks and valleys, which are as tall as the amplitude of the sine curve related to this. All right, so we want to see one graphed with stretches and shrinks in it. So let's go over here. We're going to look at this one. Cosecant, 3 times the cosecant of 2x is our curve here. And we want to pay attention to A is 3, so we're going to make a little list. A is 3, and the period, 2 pi over b, because it's related to sine, it's 2 pi. B in this case is 2, right there, and the 2's will cancel and leave us a period of pi. And this one has no phase shift because it has no term added or subtracted, so no phase shift. So we do these same questions as we do for sine and cosine. And if there was a phase shift, we would still do C over B if we needed to. But we're going to treat this like this curve, y equals 3 times the sine of 2x. We're going to graph that sine curve as a dotted line, put in the asymptotes, and then flip the u's outward. That's the progression of steps, okay? So let me put in an amplitude for my sine curve of 3 and -3. All right, I'm going to graph 2 periods of sine. Each period is pi, so I could come over, you know how I like to go over 4 boxes and make that 1 period. So between 0 and pi is going to be 1 period. And then I'll go over here to 4 boxes to the left, make that -pi, and I'll have 1 period to the left of the y-axis, and I don't have to shift it because I have no phase shift. So let me do a little bit thinner line. I can do my 5-dot pattern, beginning, middle, end, and then beginning, middle, end. And for my quarter point, I go up. There's my peak. For my other quarter point, I go down. There's my valley, and peak, and valley. So this is good review on graphing sine. And now as I draw it in, I'm going to do it as a dotted line, because this is not the graph of cosecant of x. It's merely something that helps me get the drawing guidelines down. Sorry, it's wobbly on this electronic pad. Okay. Now, you could just pay attention to the peak points and the valley points for drawing of cosecant, and pay attention where it crosses the x-axis for asymptotes. If you don't want to draw in the black dotted line, you don't have to. Let me put the asymptotes in place. Everywhere this graph crosses the x-axis, there an asymptote goes. Five of them. 1, 2, 3, 4, 5. So I must draw those in as dotted lines. Please don't ever make these solid lines. They're not part of the graph. They're just indicators that the graph does not exist there, and it helps you express that idea. Okay. But I want to see one every time it crosses the x-axis. Got some computer lag here. That's better. And then finally right here. All right, so I have my asymptotes drawn in. And now in red, I can draw my curve. I go to each peak and valley, and with my pen tool, in red. Okay, so the actual cosecant curve is in red here. What was a hill gets flipped outward to become a U. What was a valley gets flipped downward to become a hill, an upside down U. Same thing up here. And you headed toward the asymptote, but don't actually cross it. And down here, completes 2 periods. Remember, 1 period is pi on this curve, so 1 period of cosecant constitutes 1 upward U and 1 downward U. 1 period. So when I ask you to draw 2 periods, I'm asking you to draw 2 upward U's and 2 downward U's, and they alternate. All right, so let's go back and get secant, and we will be done. So here is a graph to draw secant on, and if you recall, secant is 1 over cosine. So we're going to repeat what we just did with sine, but we're going to change it to cosine. We're going to draw cosine in as a dotted curve, draw asymptotes where cosine touches the x-axis, and then invert the hills and valleys into upward U's and downward U's. Okay, so there's the 3 steps articulated right here, and you'll see what the basic graph of secant x looks like. All right, so here we go. Cosine of x, we know, has a period amplitude of 1, a period of 2 pi. Same thing for secant x, except technically we don't call it amplitude for secant. And this curve has no phase shift. So the basic cosine graph is what I am thinking of first. So if you recall, the pattern for cosine starts at 0. 1 period would take me to 2 pi. So halfway would take me to pi. And I want to do 2 periods, so I'm going to go left, put the other period over there. You can always put both of them on the right if your paper has the space for it. And those are negative. All right, so my pattern for cosine, if I make this 1 and this negative 1, there we go, looks like this. The 5-dot pattern starts up and ends up for cosine. In the middle, we're at the very bottom, and at the quarter points, that's where we hit the x-axis. All right, so I'm going to do that pattern over here. Start at the beginning of the period up, end up. In the middle, we're going to be at the minimum, and at the quarter points, we hit the x-axis. All right, now I could draw the cosine curve in here dotted if I wanted to, but I don't have to, because you know I'm going to use the upward points and the downward points are the starting points to draw all those little U's. The points sitting on the x-axis are where I'm going to draw asymptotes. So if you want a cleaner looking graph, you don't have to draw in the dotted version of cosine. I can simply go in and start drawing my asymptotes at the x-intercepts. 2, 3, and 4. So everywhere that cosine is 0, here, 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 and here, would be 1 over 0. And we know that can't exist in the graph, so we draw those. And then everywhere that we have, let's draw my curve in red, a peak or a valley, we can draw an inverted U. If the curve had been drawn in, we would invert all those pieces. So down here we would have a U that points down. And up here we would have a U that points up. And down here we would have one that points down. But this is not 2 full periods. You'll notice I've got 2 down but only 1 up, but I've got 2 dots floating out in here in space. If I really wanted to draw another set of asymptotes on the outside, I could, but all you really have to do is draw the right piece of that one and the left piece of that one, and that actually would constitute 2 halves makes a whole. So that's 2 upward U's and 2 downward U's. If you want to leave it at that, you can. If you really want to draw in the other part, that just bothers you, leaving it like that, you're welcome to do that. You don't have to draw in the other asymptotes, but also don't make your U too wide. Okay, so if you want to draw in entire U's over there, that's fine. It's okay to have more than 2 periods. All right, that's what secant looks like. So all we have left to do is to graph a translation and a stretch of secant. And so we're just going to walk you through the steps. A, in this case, 1. And then the period, same as the period of cosine, 2 pi over b. And b in this case is pi, so 2 pi over pi. Pi's cancel and leave 2. So my period is 2. And I do have a phase shift here this time. Phase shift, c over b, is going to be pi over pi, because that's c and that's b. So pi over pi is 1. And the opposite direction of the sign, plus, opposite of plus is left, negative, which is left. So 1 unit left is our phase shift. Okay, so secant is related to cosine, so I can draw in my cosine with this amplitude and a period of 2 and a phase shift of 1 left. Okay, so if I call that 1 and that 2, that's 1 period on the right. And I call that -1 and that -2, that's a period on the left. And then I know if I'm going to shift all these left 1, I'm going to have to go to -3. Okay, so normally I would have started my cosine period at 0 and gone to the end of the period here, but everything got shifted left 1. So actually the period is going to begin at -1 and end at +1. So let's do my V-shaped pattern of dots. Call that 1, call that -1. Normally V would have started up here, or cosine would have started with the V up here, gone here, and then gone down to the minimum and back up. But if I go ahead and do the shift of 1 left, instead of starting up here, up high on the y-axis, I'm going to go over here, shift it left 1 unit. And then what would have been here at 2 is shifted left 1 unit. And then I can see my way to draw in the other dots. In fact, I'm going to do it with a dark color. All right, and then halfway in between them, I'm at my min. And then at the quarter points, I'm going to hit the x-axis. And then that helps me get my next period. If a period is 4 blocks wide, then the next one is also 4 blocks wide. There's the beginning and end. At the middle, I am down. And at the quarter points, I am on the x-axis. So I could draw my dotted curve in if I want to, and that one must be dotted, but I think the dots are sufficient. What I need next is asymptotes. Everywhere I put a black dot on the x-axis, I need to do an asymptote. So here, and by the way, these asymptotes are required in the graph, and they are required to be dotted lines. so don't overlook them. They help you draw the thing well at any rate, so they are useful. Okay, so next I need to draw my inverted shape. So if I drew the cosine in dotted, it would be up, down, and up, and down, and up. And every dot that's up would have been a peak. So at every one of those, I want to invert it and draw it outward. Let's see, I want to make it green for a change. All right, so outward would be there, flipping that hill so it's a U. You could flip this hill so it's a U. You really only have to draw that half of it, but you can draw this one if you want. Try not to make it too much like a V. That one was kind of bad. It should be a nice smooth U shape. And then everywhere there's a min, I'm going to go down. If you draw the dot pattern in, it really is very easy, and you don't have to draw in the whole curve dotted to help you. Oops. Just a crazy pen here. Draw that half down. And there is 2 periods and then some of the secant of pi x plus pi. All right, I hope that helps out. Enjoy your Cyber Day.